I just want to go over how a sine wave is generated with a alternator. We've already discussed about how when you pass a conductor through a magnetic field, a voltage is induced on the conductor, and about how if you put that conductor into a loop and spin it continually through a magnetic field, you end up with a voltage being generated. This voltage, however, is going to be a sine wave. It's going to start at 0, go to a maximum value, go back to 0, and then go to a maximum value and back to 0 again in the opposite direction, the sine wave. We're going to take a peek at how this happens and how angles and all this stuff that we've talked about before in trigonometry plays out. So let's take a peek. Alright, right here we have a north pole set up and we have a south pole. I have this beautiful drawing that I've done here. Now what these A, B, C, D, E, F, G, H is a conductor. So what we're going to do is we're kind of looking at it straight on, and A, B is going to be rotating counterclockwise through this direction here. We have these dotted lines coming down here. Those are directions of flux lines heading north to south. So there's our magnetic field set up. What we're going to see here is we're going to stop it at different points. As this rotates, we're going to stop it at A, we're going to stop it at B and see what happens at C, D, E, F, G, and H, and see what happens with this sine wave over on that side there. So let's start out here. So if we start at A with my conductor is running parallel to the lines of flux, which means that there are no flux lines being cut by the conductor because it's running right along with it, which if you look over here means that we're at 0 degrees and we have no voltage being generated. So then we kick it into gear here and we start moving and we end up at a 45-degree angle. We'll stop it there. At 45 degrees, it is cutting some flux lines. You see how it's cutting flux lines there? So we are going to start getting a voltage induced. We're not going to get a maximum voltage induced, but we are getting a voltage induced. So you see that we start to generate, our voltage starts to go up to this point here at 45 degrees. And then if you notice here that we're going to go up to this peak value and then we're going to come back down, we also have the same value of voltage on both sides. That's going to be at 135 degrees. We'll talk about that in a second. So we're going to kick it up here and then we get to 90 degrees. When we're at 90 degrees, we are perpendicular to all the flux lines, which means we are cutting the maximum amount of flux lines that we have there, which means if we are cutting the maximum amount of flux lines, we are going to generate the maximum amount of voltage, which we're going to call peak voltage. So we're at our peak voltage when we are cutting at 90 degrees. Then we come back and we're cutting at 45 degrees the other way, which gets us again the same voltage that we had at 45 degrees that way, and we come down and we are running parallel at 180 degrees, which again, there's 180 degrees on our sine wave, is 0 volts. Then we start going the opposite direction. We get 225, which is 45 degrees past the 180. That gets us that voltage there. We end up at G, which is 270 degrees, which is the same as 90 basically. So we're cutting as many flux lines as possible here. And we start coming back down here. We're starting to cut less and less flux lines, and we end up back here, which gives us a sine wave of 0 up to a peak value, down to 0, up to a peak value in the opposite direction, back down to 0 again. And that is how we generate a sine wave using an alternator and 2 poles. It's not rocket scientists, not rocket science. There's not much to it. So again, just to quickly recap, as this spins around, at this point we're not cutting any, at this point we're cutting some, at this point we're cutting the most we possibly can, at this point we're cutting some, and at this point we're not cutting any, at this point we're cutting some, at this point we're cutting as many as we possibly can, at this point we're cutting some, and at this point we're not cutting any, giving us a full sine wave.